Yeah. So you could see in this particular graphics, the refrigerant. Okay, I'll just show this one. The refrigerant enters here, gets into this pocket first, moves from one pocket to the another pocket until it reaches high pressure. From here, the discharge takes place. So the scroll compressor, the top shell is the discharge shell, so always will be hot. The top shell will be always hot, unlike a receive compressor. Yeah.
Because it works on a high precision operation. I mean, is there any pressure relief valve or something?
Yeah, actually, we have pressure relief valve till up to 5 HP capacity. So pressure relief valve is used only when you don't use a HP cutout. In smaller system like 2 HP, 2-ton system, people may not use HP cutout. So where we use pressure relief valve inside the scroll. So up to 5 HP you get the pressure relief valve. Beyond that, it is compulsory for you to use a HP cutout. Yeah. So generally, actually, everyone uses the HP cutout when it comes to bigger capacity. Smaller capacity, people take chance. Where actually we have pressure relief valve. Internal, because of IPRV, internal pressure relief valve, that is there in that. Okay, that's how it takes place. The top shell will be always discharged. It will be a discharge temperature. While handling the scroll compressor, you have to be careful because top shell can go up to even 100 degrees centigrade or so. So you have to be careful while handling the compressor when it is especially running, touching these parts and all that. And don't run any wire on the top. There is a possibility if the temperature increases. It depends on the quality of wire. The wire can melt and all that, right? So you have to ensure that there is no sensor or wire passing on the top of this as well, yeah, while just installing. So our compressor, we call it as a compressor with dual compliance. So it has a radial compliance as well as axial compliance. So radial compliance is this. The radial compliance is the compressor scroll flanks get separated from each other when the liquid enters inside. So generally when the receive compressor, when the liquid enters inside the cylinder, you cannot compress liquid, right? We can compress only vapor, we can't compress liquid. You are trying to compress a liquid, what it does is it will break your reeds. It may break your valve plate, right? It may break your gaskets. We call it as blown gaskets, right? It can break because it tried to find a least path of resistance to go out. So you can blow your gaskets and all that. Even small liquid handling will be very difficult for receive compressor, but when it comes to scroll, it can handle much better liquid compared to receive. Because what it does, the radial compliance, what it does is, basically the earlier video, there is a contact made between fixed scroll and the variables, the fixed flank, scroll flank and the orbiting scroll flank, orbiting scroll and fixed scroll. So there is a contact is made in the sideways also the contact is made, right? So that contact is made because of the centrifugal force. When you are running at 2900 RPM, there is a centrifugal force because of which the contact is made between the scroll flanks. When the contact is made, so there is no bypassing of the gas from one pocket to another pocket. So the gas will be moving from low pressure to high pressure towards the center. There is no bypass of refrigerant. So when the liquid enters inside, by mistake, when the liquid enters inside the scroll flank, it will become a hydraulic pressure. That pressure is much higher than the centrifugal force, what is talking about, right? What we are talking about. So since hydraulic pressure comes in, these scroll flanks get separated from each other and allow the liquid to pass through in the center. You just go and get out from center of the scroll. So, but it doesn't mean like you can put any liquid. No, it is better than receive compressor and other technology, like definitely better than rotary. Rotary cannot handle liquid. Receive cannot handle liquid much, but this can handle much better liquid compared to rotary or receive compressors. Yeah. So that is one more advantage of scroll compressor. And we have axial compliance. So axial compliance is based on like when the scroll normally running, that these points need to touch each other, right? These points touch each other, as well as this tip supposed to touch here and this tip supposed to touch here. Then only the bypass won't happen, the compression takes place. Right? The pockets are properly formed and compression takes place. And when the liquid enters here, because of the very high hydraulic pressure, what it does is, it will push this fixed scroll up. Even though we call it as a fixed scroll, the fixed scroll can go up and down by 1 mm. So when it push up, then actually it will be bypassing here, and the liquid just go out from this. So both the ways you are avoiding liquid getting compressed and we are just getting out of the scroll compressor. Yeah.
Okay, but there is some refrigerant that is recommended to charge liquid like 400 07 400 010. Okay, during the charging, if we start it to recharge the unit with off, okay, we'll give some liquid. Then during the start, we need more gas.
Yeah.
In this time, how we charge the liquid?
Yeah, it's a good question. The thing is, whenever you use scroll compressor, not only ours, any manufacturer, any scroll compressor, when you're charging the system, at least 70% of the charge will be in liquid form in the receiver or in the high side. You may not have a receiver in all these systems. On the high side, on the liquid line, you charge like 70% of the refrigerant before starting the compressor. So it should be only on the liquid side, not in the suction side. After starting, you can have a controlled liquid charge into the suction. Controlled liquid charge is like you have a manifold, open, close, you can charge. That way you are not allowing the liquid to directly get into the screw. So that you need to ensure when it is running. Yeah, you need to ensure. That is very important because 410E again it is zero flow. Whatever refrigerant starts with 4, it has a temperature gland. It has to be charged as liquid only. And scroll any refrigerant, even R22 you are charging, you have to charge as a liquid 70% before you are charging remaining refrigerant in the suction.
Okay.
So approximately you know, before charging you should know for this system how much refrigerant will take. If it is a package unit, the OEM manufacturer will specify the quantity, right? Then you know. If it is a 10 kg, you put 7 kg in the liquid line, then remaining 3 kg after starting it slowly charge in the suction line.
If we put the 10 kg, what will happen?
Huh?
That we able to put 10 kg all together?
You can put it, but generally like when you are trying to do it, you may overcharge it also. But if you can put it, it is not done in factory. When it's a OEM manufacturing package unit, they put all the 10 kg in liquid line.
Okay.
But in the field when it comes, people may not be carrying weighing gauge and all that. You may not be knowing exact quantity.
Yes.
So approximately when you are doing it,
Yeah.
so put 70% approximately on the liquid line, then remaining slowly you charge in the suction line and get that pressure, right?
Yeah.
I'm not seeing many people carrying a weighing gauge to the site. Right? You only see suction pressure and see whether return is coming and you try to charge. Maybe if you have a side glass, you look at the side glass, right?
Yeah.
So that time, like when you're doing approximate, you're like 70% approximately put it on the liquid side, remaining you put it on the suction side, slowly charge in the suction side. So suction you are slowly charged, controlled, you can just open the manifold, close it, open, close. With 30% charging will be easier rather than 100% you are trying to charge in the suction. That is one. Other thing is, these scroll flanks are lubricated by the oil mist carried by the refrigerant. The oil mist when it is circulating, you know, whenever you have a leakage, you find oil coming out, right?
Yes.
So oil is always in the circulation in the system. So at least like we say 1 to 1.5% oil will be always in the system. It will be circulating in the system. So that oil, whichever is the mist form, it is coming back and all that. So inside the compressor what happens is, there is no separate lubrication for these areas. This lubrication is taken care only by the refrigerant which is inside. When the refrigerant goes back carrying the oil, that refrigerant with the oil mist will be lubricating these parts. So when you start the compressor without enough refrigerant, say I want 10 kg, but I just started charging with 1 kg and started the compressor. What happens is, there won't be any enough oil coming to this portion get overheated. When it gets overheated, you have a bearing here. The operating scroll bearing is here. When this gets overheated, the operating scroll bearing gets overheated. When the bearing gets overheated, the oil won't stay. Right? Oil has some viscosity. The viscosity reduces with the temperature. When the temperature increases, oil viscosity will come down. So when the temperature increases here, this temperature will be passed on to here. This temperature also increases. Because of high temperature, the oil viscosity will come down. It cannot stay there. It will fall off. Then there won't be any lubrication here. And this also fails. Not only like we have problem here also this bearing also fails. So to take care of that, any scroll compressor when you are charging, at least 70% you put it in the liquid side before starting the compressor, and you can charge slowly after that. Don't just equalize the pressure. Okay, put the refrigerant in the vapor form, cylinder and system get equalized with the pressure, then start the compressor and charge. It may work for some time, but the reliability of the compressor, these compressors are supposed to work for 15-20 years. But if you are not following those, these compressors may fail in 6 months or 1 year. So that is not expected out of this compressor. These compressors need to work for 15-20 years. So you need to follow the proper the charging process, which can take care of this. It's very, very critical actually. When it comes to refrigerant, the scroll compressor, whether refrigeration application or air conditioning application, you need to charge 70% before starting the compressor. You should not bypass the LP cutout. So you always do, right? When the semi-automatic compressor, all that, we bypass it. After getting the pressure, you just do it. We are not supposed to do this. That is one more checkpoint. Don't bypass it so that like you charge enough before starting it. You have enough pressure before you starting the compressor. So that will be taking care of this lubrication.